Good morning, children. This session we are going to discuss about some important points, right? So what are the things we are going to discuss today? One is about chemistry, matter, energy, intensive property, extensive properties, substance, followed by elements, metals, non-metals, metalloids, compound, mixture, alloy, physical change, chemical change, followed by law of conservation of mass. So these things we are going to discuss today. First, let us start with chemistry. Chemistry is the branch of physical science which deals with structure, composition of matter. Okay, structure and composition of matter. Right. There are different branches of chemistry are there. Among the different branches, the main branches of chemistry are organic chemistry, inorganic chemistry, and then physical chemistry, analytical chemistry, biochemistry. These are some of the main branches of chemistry. I hope already you have learned about these branches of chemistry in your first lesson, isn't it? Okay, let me recall now. So, what is meant by organic chemistry? Organic chemistry deals with carbon and its compounds. Okay. Whereas if we take inorganic chemistry deals with compounds other than carbon compounds. Okay. Carbon compounds means that deals with organic chemistry. Other than carbon compound means that will come under the category of inorganic chemistry. Okay, next one is physical chemistry. Physical chemistry deals with the study of structure of compounds. Okay, structure of compounds is it mentions the physical chemistry. And next one is analytical chemistry. Analytical chemistry, it deals with the study and uses of instruments. This is very important. Study and uses of instruments means it is nothing but analytical chemistry. And biochemistry deals with the biological process of a living organism. These are the main branches of chemistry, right? Chemistry deals with the study of properties and composition of matter, and the main branches of chemistry are organic, inorganic, physical, biochemistry, and analytical chemistry, right? Good. Next we can move to matter. Define matter. What do you mean by matter? Matter means anything which occupies space and has weight are called matter. Then how many states of matter are available? There are 3 states of matter. One is solid, another one is liquid, and third one is gas. There are 3 states of matter, right? So look at the board. Matter can exist in matter means anything which occupies space and has weight are called matter. Matter exists in 3 states. One is solid, liquid, gas. Even though matter exists actually in 5 states, okay. But the main 3 states are solid, liquid, and gas. 4th state is the plasma state and 5th state is the Bose-Einstein condensate. When you go to higher classes, you will learn about the 4th state of matter and 5th state of matter, right? So this matter is again classified into pure substances and mixtures. Okay, pure substances means constant composition will be there, whereas mixtures means variable composition. Composition may vary here in mixtures, right? Good. Next one, pure substance. Again, it classifies into elements as well as compounds, right? Here, mixture can be classified into 2 types. One is the homogeneous mixture, another one is the heterogeneous mixture. Okay, children? Right. Next, we can move to energy. Energy is the ability or capacity to do work. One type of energy can be converted into another form of energy. Okay, one form of energy E is equal to mc square. So this is Einstein's equation. Okay. Here he mentions this. E mentions the energy, whereas m is mass and c is velocity of light. This is the Einstein's equation. The relationship between energy as well as this is the relationship between mass and energy. Okay. So E is equal to mc square. It is given by Albert Einstein. When you go to higher classes, we will learn about the Einstein's equation, right? So next we can move to intensive property. Intensive property means these properties do not depend upon the amount of matter. Okay, intensive properties do not depend upon the amount of matter. For example, melting point, boiling point, color, temperature. These properties do not depend upon the nature. Okay, so that is called intensive properties. Next one, extensive property. Intensive property means what I told you for intensive property. These properties do not depend upon the nature of the properties. Okay, that is, they do not depend upon the amount of substance. Okay, amount of substance. Usually, intensive property do not depend upon the amount of substance. That is called the intensive property. For example, color, temperature, melting point, boiling point, these things will come under the examples of intensive property. Next, if you take the extensive property, it depends upon the amount of the substance. Okay, it depends upon the amount of the substance. For example, mass you can say. Okay, so mass will come under this one only, that is extensive property. Next one, come to the substance. Substance means what? Pure substance. It can be classified into elements as well as compound. Okay, pure substance can be classified into element and compound. Next one is element. And what is meant by element? It is made of atom. Okay, it is made of atom. If you look at the periodic table, so this is the periodic table, nearly 117 elements are present. Okay, 117 elements are present in the periodic table. Among the 117 elements, nearly 88 elements are obtained from natural sources. Okay, isolated is nothing but obtained from natural sources, whereas 29 elements are prepared in artificial manner, that is in laboratories like that. Okay, so how many elements are present so far? 117 elements are present in the periodic table. Out of these 117 elements, 88 elements are present in from natural sources, whereas 29 elements are prepared in the laboratory. Okay, these elements generally classified into two types. One is the metals and another one is the non-metals. Okay, these elements are represented in the periodic table by using symbol. Okay, symbol stands for some meaning. So for each and every element is represented by its symbol. So symbol means what? It is the shorthand notation, short form by representing the symbol. Okay, that's what in the periodic table we are using the symbols. Right, children? Good. So next we can move to the metals. So I told you elements can be classified into two types. One is the metals and another one is the non-metals. It is very important to know about the general properties of metals. In the periodic table, the left side of the elements are metals, whereas right side of the elements, okay, are non-metals. Non-metals are positioned at the right side of the periodic table, whereas metals positioned at the left side of the periodic table. When compared to non-metals, metals are amount is very heavy. That is, metals are large in number when aluminium, okay, calcium, zinc. These are some of the metals that we use in our daily life. Usually, metals are solid under the given temperature. Okay, metals are solids. Metals are very hard in nature. Generally, metals are very hard. They have high density. Also, they have high melting point as well as boiling point. Okay, and metals, it has the malleability property. Malleability means metals can be hammered or beaten into very thin sheets. This property of metal is called malleability. Okay, and also next property is ductility. Metals are ductile in nature. What is meant by ductile? Generally, metals can be drawn into very thin wires. This property is called the ductility. Okay, example, copper wire. We can say we can draw the wire. We can draw the copper wire, isn't it? So, if you draw the metal into thin wire, then it is the property of the ductility. It has a ductility property. Example, we can say copper wire, right? Aluminium. Even here, aluminium also is used in cables for making cable, isn't it? Right. Next one, metals generally conduct electricity. Okay, metals conduct electricity. And metals on being hit, metals produce a sound. Hence it is sonorous in nature. Sonorous means sound. And also most of the metals are shiny in nature. Okay, it is very lustrous in nature. Lustrous is nothing but shiny appearance, right? This typical shine of the metal is called the metallic luster. Okay, typical shine of the metal is called metallic luster. These are the general properties of metals. Then what are the uses of metals? You know very well, gold and silver are used for making ornaments, isn't it? And iron is used for construction purpose, that is used for constructing the bridges, okay, bridges and also iron bars, engine bars like that. Okay, aluminium is mainly used in aerospace industries and also in cable wires, right? Okay, so these are some of the uses of metals. Next we can go to the non-metals, right? Non-metals, it occurs, some of the non-metals are oxygen, hydrogen, carbon, sulphur, phosphorus. These are some of the non-metals. Mostly gas, it will come under the category of non-metals. Okay. So, non-metals, it occurs in all the three states of matter. That is solid state. Non-metals occur in solids, not only in solid state, even in liquid state as well as in gaseous state. Okay. For example, if you take phosphorus and sulphur, both it will occur at the solid state. Whereas, if you take nitrogen, oxygen, hydrogen, it will come under the category of gaseous state. Whereas bromine is available in the liquid state. Okay. So, non-metals occur in all the three states of matter. Right, children? Good. Next one, non-metals usually do not shine. It does not have the lustrous property. It has dull appearance. Okay. And the non-metals are soft in nature. What I told you for metals, metals are hard in nature. But non-metals are soft in nature. But the only exception is diamond, which is obtained from carbon. Diamond is the hardest naturally occurring substance. Okay, diamond only is very hardest in nature. Other non-metals are soft in nature. Okay, and next non-metals have low density. Non-metals have low melting point, boiling point. Non-metals are non-malleable in nature. That is, on hammering, it cannot change into thin sheet, right? And non-metals are non-ductile in nature. You cannot drawn into wire. Okay. Next one, non-metals do not produce sound when hit. Okay. And non-metals, it will not produce sound. At the same time, Non-metals usually it will not conduct electricity, but the only exception is graphite. Graphite conducts electricity. Graphite is a non-metal only, but it is obtained from carbon only, like diamond. So this graphite, even though it is a non-metal, it carries electricity. Got it, children? Right. Then what are the uses of non-metals? If you take hydrogen, hydrogen is generally used as a rocket fuel. Okay, hydrogen is used as a rocket fuel. And the diamond, which is obtained from carbon, it is mainly used for, very well. It is used as an ornament, and also it is used for cutting purpose. Okay. And the next one, sulphur. Sulphur is generally used for vulcanization of rubber, as well as it is used as a gunpowder. Okay, it is used, that is in the explosive. It is used as a gunpowder. And the graphite, it is used in pencil leads. Okay. Next one, phosphorus. Phosphorus is a non-metal only. This phosphorus, it is mainly used in preparing the matchbox. Okay. Matchbox contains red phosphorus. That phosphorus is a non-metal. And nitrogen is used for used in fertilizers. Okay. So these are some of the uses of non-metals. Right, children? Shall we move to the next one? Yes. Next one is metalloids. So far we have discussed about metals as well as non-metals. Then what is meant by metalloids? Metalloids means the elements which exhibit both metallic character as well as non-metallic character. Okay, elements which exhibit both character, that is metallic character also it will exhibit, as well as non-metallic character also it will exhibit. Then it will come under the category of metalloids. Metalloids means both metallic character as well as non-metallic character. For example, boron, silicon, germanium, polonium, arsenic. These are some of the metalloids. These elements contain both the properties, metallic property as well as non-metallic property. Got it, children? Right. So next one we can move to compound. Compound is composed of atoms. Okay. Compound is composed of two or more different elements. Okay. Compound is composed of two or more different elements. For example, sodium chloride is a compound because it contains sodium element as well as chlorine element. Water is a compound because it contains hydrogen element as well as oxygen element. Okay. So compound means what? Elements which contains compound is composed of two or more separate elements, that is called a compound. Right, children? There are two types of compound. One is compounds can be classified into two types. One is the organic compound, another one is the inorganic compound. Okay. What is the difference between organic compound and inorganic compound? Organic compound deals with living organisms. Okay, compounds which are obtained from the living sources, living organisms are called organic compounds. For example, proteins, carbohydrates, we can say example for organic compounds. Compounds which are obtained from living sources are called organic compounds. Whereas inorganic compounds means compounds which are obtained from non-living sources such as rocks, minerals, etc. Example, this chalk, baking powder. These are some of the inorganic compounds because they are getting from what? Minerals. Okay. So inorganic compounds are obtained from minerals, whereas organic compound obtained from natural source. That's the difference between organic and inorganic compounds. Next one, mixture. Mixture, it is a material made of two or more substances. Okay. Mixture is a material made of two or more substances. There are two types of mixtures. One is the homogeneous mixture, another one is the heterogeneous mixture. So mixtures, it has variable composition. The composition may vary and it can be classified into homogeneous mixture and heterogeneous mixture. What is the difference between homogeneous mixture and heterogeneous mixture? If you take homogeneous mixture, For example, if you add salt in water, after mixing it, what do you observe? You will observe the only one solution. That is called homogeneous solution. Okay. So next one, heterogeneous solution means solution contains two components, more than that. Okay. That is homogeneous mixture means single phase. But here in heterogeneous mixture, more phase you can see. For example, if you add chalk powder in water, mix it well. Even though if you mix it well, it will not get mixed. You will see the two phases. One is the water phase, another one is the chalk powder phase. Okay. So this is the difference between homogeneous mixture and heterogeneous mixture. Got it, children? Right. So next we can move to alloy. Alloy means it is nothing but homogeneous mixture of two or more different elements. Okay. These elements may be either metal and metal, or metal and non-metal, non-metal and non-metal, like that. Okay. So these are called alloys. For example, brass, bronze and all we can say an example for alloys. Alloys means what? It is a homogeneous mixture of two or more elements. Got it? Right. Next one, physical change. Physical change is a temporary change. Okay. And also it is a reversible change. Here, no new substance is formed in the physical change. Got it, children? Physical change is a temporary change. It is also called the reversible change. Reversible change means again you can brought back the solution into its original form. And also this physical change is a reversible change I told. And another one is a temporary change. And here no new substance is formed during physical change, right? Next one, chemical change. Chemical change is a permanent change. Okay, chemical change is a permanent change, and also it is an irreversible change. Okay, again you cannot bring back the solution into its original form. And also chemical change is an irreversible change, and also it is a permanent change. The next one is new substance is formed in the chemical chain. But in physical chain, no new substance is formed. In chemical chain, new substance is formed. Got it, children? That's the difference between physical change and chemical change. Next one, the last one is law of conservation of mass. Who proposed law of conservation of mass? Lavoisier. Lavoisier proposed the law of conservation of mass. Okay. According to the law of conservation of mass can neither be created nor can be destroyed. Okay. And also during chemical changes or during chemical reactions, the total number of the reactant is equal to the total number of the product according to Lavoisier's law of conservation of mass. Okay. Law of conservation of mass was proposed by Lavoisier. According to him, mass can neither be created nor can be destroyed during chemical change, and also during chemical reaction, the total mass of the reactant is equal to the total mass of the product. This is the law of conservation of mass. Right, children? So, many things we have discussed today, isn't it? So, everything you have to go through once, and also in the next class we can discuss about chemical equation, scientific notation and significant figures. Right, children? Thank you.